Welcome to the American Institute of Cloud Auditors AICA Sky Blue Book Series YouTube channel. I'm your presenter and principal author, Robert Llewellyn Kilby. You are invited to sit back and relax as I present a high-level overview of IT auditing principles and concepts for this 21st century of cloud, artificial intelligence, the Internet of Things, and blockchain technologies. You will see how the American Institute of Cloud Auditors, AICA, has set the financial statement auditing standards for the 21st century business operating environment of cloud, the Internet of Things, artificial intelligence, and business blockchain technologies. You will also see how the American Institute of Certified Public Accountants, the AICPA, and the National Association of State Boards of Accountancy, the NASBA or NASB, have recognized the pressing need to mitigate the disruption information technology continues to cause financial auditors by developing the new CPA Evolution Model Curriculum ISC discipline. One of the three new CPA credentials accounting students will vie for when they sit for the three new CPA exams beginning 2024. The ISC discipline relates to IT auditing, the BAR discipline relates to financial reporting, and the TCP discipline relates to taxation. But first, the table of contents of this presentation. This presentation begins with computer systems defined in the context of IT auditing, followed by computer-related terms that can be confusing. We also talk about the evolution of computing architectures, the evolution of computer systems, the audit universe in various compute environments, framing the audit engagement to avoid scope creep, a required change in financial auditors' mindset, outdated generally accepted auditing standards or GAS, inadequate financial auditing tools, evidence in the paper-based versus a computerized environment, AICA IT auditing methodology and electronic evidence gathering, new audit risk and inherent risk for cloud computing environment, emerging technology and the relevance of each chapter in AICA books to the integrated audit of financial statement controls and the internal control over financial reporting, ICFR, and then the conclusion. But first, the computer systems as defined in the context of IT auditing. As a segue into this new way of thinking about financial auditing in this 21st century business operating environment, let's review various types of systems. We have general ledger systems, we have medical device inventory system, we have hospital system, we have video production system, we have government tax assessment systems, IRS tax filing system that interfaces with TurboTax, and two or more of these systems integrated. These are examples of what can be characterized as systems in the context of auditing. So in the context of auditing then, the term system must be clearly defined to understand the scope of the auditor's work. Now let's look at computer-related terms that can be confusing. Terms that are often used interchangeably that can be confusing are computer science, or CS, information systems, IS, management information systems, MIS, and information technology, IT. So computer science is a technical field that deals with the study of the underlying principles of algorithms, the mathematical property of algorithms, how computer hardware components can be manipulated by the use of algorithms, how the algorithms can be implemented in programming languages, and how to develop applications from the programming languages. And next is the information systems terminology. Information systems, or IS, is a catch-all term for computer people and processes that are designed to generate, store, manipulate, distribute, and disseminate data and information. Information systems bridge the gap between business and computer science. Now, information technology, or IT, is a subcomponent of information systems and is the use of computer to store, retrieve, manipulate, transmit, and disseminate data information in the operations of a business. So IT is a subcomponent of information systems. Management information system, finally, is the use of resources such as computer files or a database to generate management report to make decisions about various aspects of a business. So these terms should be, these definitions should clarify the interchangeably used terms that can be confusing. Now, business process control versus IT general controls, commonly known as ITGC in the context of IT auditing. Generally, IT audits that will be conducted under the AICPA NASB new CPA evolution model curriculum ISC discipline will cover two sets of processes: automated business processes and technical processes. Today, 75 to 90% of business processes are automated. And then the technical processes, 100% of them these will be tested under the ISC discipline, and these are processes that run the business operations. So business process controls. In the context of IT auditing, when we talk about business process controls, we are talking about controls that enforce laws, business rules, and regulations. For example, the controls that implement accounting rules to make sure debit equals debit, credit equals credit, as an example. Financial accounting rules, cost accounting rules, federal tax laws to make sure they're consistent with what Congress passed, state tax laws, for example, banking regulations, to make sure they're in compliance with federal and state banking regulations, and industry-specific regulations and SOX regulations, etc. So all of these tested the controls that ensure that these rules and regulations are implemented in the computer systems are referred to as business process controls. Now, technical process controls, from a technical process controls perspective, the audit includes examining, testing, and reporting on how the accounting and financial data customers, employees, suppliers, and clients enter into the system via numerous interfaces such as on the online screen, subsystem interfaces, is processed and reported. For example, that the database management system stores and manages the business data. Computer programs are calculating, converting, and translating the business data according to requirements. Computer network are transporting the business data between computers, and computer security subsystems is protecting the business data and the computer programs that are storing and processing and transmitting business data. So these are the controls that are implemented from a technology standpoint. The evolution of computing architecture. The following schematic illustrate the various computing architectures that have evolved over the years. When you are planning internal control over financial reporting type audit, you will find out that they are significantly and uniquely different under each of these four computing architectures. The first architecture is the mainframe computing architecture. In the mainframe computing architecture, you have mainframe that are confined to a space at the corporate headquarters, normally, with dumb terminals, employees using dumb terminals. And they are referred to as dumb terminals because these terminals do not store information locally as on PCs and tablets. All they do is access the application from the mainframe's perspective in the mainframe room, and everything is done on the mainframe side. So they are referred to as dumb terminals. And the system admin is also within the confines of the mainframe room, the computer room, and controls the programming, who has access to those, and so on. So in a mainframe environment, you have a very, very confined and centralized processing going on mainframe systems. Contrast that to a client-server computing environment. Under this architecture, you have specialized servers, for example, print server, you have multimedia server, you have mail server, you have database server, you have internet server, you have file servers. All of these servers are performing specialized tasks, and each department within the organization is accessing these servers, for example, through Active Directory services that points an employee or a user directly to the path of the server, to the server or the programs that he is entitled to perform his work. Likewise, the CEOs, CFOs, and CTO have their own specialized servers, and they also go through Active Directory to access their information. And there is a lot of security performed at this level, at both the application and the server level. Now contrast that to a managed service provider environment, whereby a managed service provider environment is where a managed server has a data center, and the company or corporate companies are carrying, they take their servers to the managed server data center, and they have different branches that are accessing the data. They provide internet connectivity through metropolitan area network or wide area network, and the company assets, their information assets or their servers are at the managed server provider's location. So in the context of IT auditing, the IT auditor has to visit the data center where these servers are located to perform what we call physical security, making sure that those servers are secure, access to the servers are secure, and the performance of the actual audit of application is done at the regional and overseas location, as you can see in Asian branch, South America branch, EMEA branch, and so on, as well as the regional corporate headquarters. So the actual application is being accessed from there. So IT auditing will span the entire paradigm as described on screen. And now the cloud computing environment is whereby all of the existing institutions and different service providers have their own cloud. We have three different types of clouds. We have federated cloud, we have private cloud, and public cloud. So in the context of IT auditing or financial auditing, you have, for example, the IRS have their own cloud. The financial institution, banks have their own cloud. Payroll system service provider have their own cloud. The industry blockchain services have their own cloud, and network security as a service, a technical cloud that protects the entire infrastructure for the company, and so on. So in a cloud environment, these different clouds are processing the company's data compared to the mainframe environment, and they are sending the data over through different channels, communication channels and network, the internet specifically. And so then in addition to this, you have the Internet of Things, where people are accessing these different financial institution cloud, payroll cloud, and so on, and updating them through their tablets, cell phones, smartphones, and so on. But still, we have the accounting department that have its own cloud within the company perimeter, and the company has its private or federated cloud, and the CEO and everybody else is attached to these different cloud systems, and the cloud systems are pushing data over to the different services that have been performed for the departments within the company. And finally, this is a derivative cloud environment, whereby these are referred to as derivative services from a cloud standpoint. Security as a service has its own cloud, platform as a service, entitlement as a service, identity as a service, software as a service. These are all third-party cloud that are performing security, software services, providing, identifying who can access the various resources, company resources. So these are referred to as derivative cloud services, but they are just having, they're providing services to to manage access to the company data within these various cloud infrastructures. Now, the evolution of computing architecture. As computer system architecture evolved over the years, business computing services have become more distributed and autonomous, and auditing through the computer has become intricate. For example, during the mainframe era, auditing around the computer was acceptable and the prevailing standard. So auditing around the computer refers to the player's situation in the mainframe environment whereby the reports are printed out and the auditors take a look at the reports, as we saw in the dumb terminal situation. So we were auditing around the computer during the mainframe environment. During the client-server environment, we're auditing through the computer. And that is in the web-based, the managed server, and cloud environments. That's because of the different services that were being performed. So instead of printing our reports, we had to access databases on the client-server machine. The different servers you saw had their own databases and their applications and reporting. So you have to audit through the computer. It's referred to as auditing through the computer when you have to examine reports that are in databases and files and so on. Now, the evolution of computer systems. The first generator of computer system in the mainframe world was data processing system. Then we came into a management information system, if you remember from the definition, where we were informing management about giving management information about their business operations. Then we came into a decision support system, where the system had much more intelligence, and based on previous data and the current environment, it was making decisions, assisting management to make decisions. Expert systems came as the fourth generation, whereby they were programming expert knowledge or decision-making process into programs, and the programs were subsequently using that knowledge to make projections in the future. Now we have artificial intelligence and machine learning, and they are cloud enabled, but these have increased the amount of utility that computer systems can provide to individuals, such as performing based on inferences, making projections as humans would reason up, and so on. So machine learning and artificial intelligence are trying to mimic human interaction or human decision making. Now let's take a look at the audit universe in various compute environments. So again, the audit universe in the mainframe environmental characteristics include job streams, centralized processing, physical security restricted to a confined area, and no client-side business intelligence. That's what we discussed earlier. So we have different jobs that are running on the mainframe, as you saw in the previous diagram. The characteristics, the audit in the audit universe of a cloud environment, the characteristics include a multiplicity of cloud service provider. As we discussed, you got payroll cloud, you got accounting cloud, banking cloud, tax cloud, and so on. So all of the processing is decentralized within those cloud systems, various clouds, and the information is being sent to the appropriate corporate application or database, and they are being accessed by employees and executives. It also has physical security is managed independently by each service provider, because each service provider has its own cloud, and we have extensive client-side business intelligence, meaning that the smartphone edge computing or a lot of processing is occurring. For example, when you register for your courses and you have a shopping cart, it's done locally on your machine. You set up the shopping cart, and when you're done, you push it up to the system, and then it processes your registration information. So then the audit universe in the blockchain environment. In a blockchain environment, the characteristics include a multiplicity of cloud service provider, immutable centralized distributed ledger, a physical security managed independently by each service provider, as we saw in the cloud environment, and extensive client-side and server-side business intelligence, but highly manageable. In a blockchain environment, you have a centralized ledger, which is immutable. The immutability of that ledger restricts any alteration of information once it's entered in there, everybody can see it. So instead of companies having their own general ledger and then reconciling with other companies, you have this centralized general ledger and everybody contributes to it, and each participant in that blockchain can see only their information they are privileged to see. Now, framing the audit engagement to avoid scope creep. Scope creep is a key issue when you're conducting IT auditing or any type of auditing for that matter. So each audit solution discussed in our presentation will relate to one of several of the preceding system architectural configurations. So by referring to these compute paradigms, keep a frame around the discussion and prevent scope creep. We define the system boundaries and the elements that constitute the control environment by placing logical marker around the system perimeter. That is in the case, for example, with the IRS and TurboTax scenario I discussed earlier. If you were hired by the IRS to perform an end-to-end audit of the IRS and TurboTax, then you would have to put the boundary around the entire process. But let's say, for example, TurboTax hire you as an IT auditor to perform their aspect of the IRS interfacing the systems, then you will have to restrict that access to the interface that the TurboTax does with the Internal Revenue Service, but you're not privy at that time to audit the Internal Revenue Service. So putting a parameter around it just means that you are identifying how the system is being defined. A required change in financial auditors' mindset. Financial auditors must change their mindset from auditing paper-based audit evidence, referred to as auditing around the computer I referred to earlier, to auditing financial data stored in databases, files, somewhere in the cloud ecosystem, with data traveling over computer networks which can extend beyond national boundaries and sometimes into outer space, referred to as auditing through the computer. So when you're auditing through the computer, you are not looking at a piece of paper that says this is the payroll, or a document that says this is the payroll. You are looking through the computer systems and databases to see how the data captured in those databases are being translated to what is referred to as this paper-based payroll or the payroll check. Outdated generally accepted auditing standards, or GAS. The current generally accepted auditing standards, or GAS, was intended and suited for audits of financial statements that are generated in a business operating environment consisting of principally manual processes, a centralized mainframe, a centralized computing environment, mainframe, no change sense. So traditional banking system, paper-based evidence, a local or national customer-based snail mail services, and minimal networking capabilities. So the current generally accepted accounting standards stopped at the mainframe level. It was attributable to the mainframe level with no change sense. So as we talked about, when they evolved from mainframe to client server to managed server to cloud to blockchain, there has been no updates done to the generally accepted accounting principles. So the presumption here is that you still have a manual process, a centralized computing environment, traditional business process, paper-based evidence, and so on. Audit evidence as seen through the lens of the traditional auditor, which is auditing around the computer, as I said, is reviewing paper-based evidence such as purchase requisition, invoices, bill of lading, canceled checks, bank statements, and all of these require printing. When auditors went to audit in the mainframe environment, they had to print out all these documents. You had to do the check reconciliation, you had to do bank statements, look at bank statements, and so on. And when the spreadsheet came in, then they started to download some of these bank statements to there. You had to sort it and do all kinds of manipulation to be able to derive your audit evidence. So the traditional auditing around the computer means everything is paper-based as seen on screen. Now, audit evidence as seen through the lens of IT auditor, aka auditing through the computer, requires examining electronic evidence such as the database, electronic file, looking through system metadata in the cloud, based network platform. We're looking at software as a service, platform as a service, internet as a service, the operating system and application log. You got to examine e-banking platform now. Not only that they send you all these transaction logs, but you have to look through the system log and as well as the transaction log. E-commerce, you've got to examine the system log to see who's accessing the system and where these transactions are coming from. So auditing through the computer requires querying data stores, conducting some computer forensic investigation to determine where the data is coming from, data analytics, and using automated tools and platforms and techniques. Inadequate financial auditing tools. The current population of financial auditing software and tools in the marketplace fall into three distinct categories. They are either document management system, they are query tools, or they are configurable workflow platforms. Now you have some of the software developers out there that are developing these platforms and tools make unsubstantiated claims to the effect that their products are Sarbanes-Oxley compliant or they are AICPA preferred. So the issue with the claim that a single software or tool or platform is Sarbanes-Oxley compliant is false, because some of the generally accepted accounting principles GAS the PCAOB adopted from the AICPA have become obsolete for obvious reasons we stated earlier. For the current compute environment, you're talking about cloud, blockchain, Internet of Things, artificial intelligence, and machine learning systems that these tools cannot even interface with or probe. And also, generally accepted accounting principles has three standards. They are general standards, standard of fee work, and standard of reporting. So no single tool or platform can satisfy these three standards, and the destination of a platform as being AICPA preferred platform is misleading, grossly misleading. In the context of a paper-based environment, a document management system can be likened to a file system hanging folders in a file secure from securing the auditor's work papers that are indexed. So these platforms that are out there that are saying that they are auditing tools are actually generally used by various professions, including the legal as well. So a document management system functionality includes storing or electronic files or evidence, organizing the files, organizing audit work paper, and linking electronic evidence to audit components. So these are just facilitating the audit process. They are not actually auditing tools. In the context of IT auditing, query tools have limitations with respect to how the tool is calibrated. The tool configuration, access right granted to auditors, data security, warehouse security, and the role of the database management system admin in the audit process. So the limitation that these query tools have are restricted access to the DBMS resources, so the database administrator can restrict the auditor's access. They might give auditors end user or employee level access, querying financial data, storing tables, and the data can be one-dimensional, and you might want to do more than one dimension. Query tools should be used in reverse engineering type test scenarios, and the relevant test procedures should be planned and executed methodically with expected results. So again, the query tools and the privileges that will be granted to auditors to utilize these query tools can be done at a certain level that will undermine the audit work. So in the context of IT auditing configurable workflow platform, as I said, it enables restricted access to the relevant deliverables in the audit process. It implements and enforces review controls, approval controls, enforces promotion controls, interfaces with document management system. So these configurable workflows that they are claiming are auditing tools are just facilitating the audit, because the workflow just restrict who can review documents, who upload documents, whether the partner in the firm can approve the document, promotion to the next, and interfacing with document management systems. So these are things that help to manage the audit process, but they are not actual auditing tools. So now let's look at evidence in the paper-based environment versus evidence in the computerized environment. So the physical description of this book from a paper-based evidence standpoint, if we were to look at the first volume of our books, 33 chapters, 362 pages, 33 tables, 62 figures, we printed that book out, and this is the evidence that we can get with respect to our first volume of the book. So we are auditing around the computer, meaning that we did not get into the system to be able to know how many, know any further detail than what was printed on those books. So now electronic description of the same book, we know that we have 33 chapters, we have 362 pages, 33 tables, 62 figures. But also, in addition to that, we can query the database to know we have 75,738 words. The file was created on January 3rd, 2018 at 11:37:20 p.m. or a.m. 30 frames per second, video screen frames per second for videos that we're using to describe it, and 9.25 soft copy file size megabytes of the book cover. So we have all kinds of details that we can get if we were using the electronic description of this book rather than just printing this book. So this should show you the difference between looking at a physical piece of evidence in a manual audit environment versus how intricate we can get a detail with respect to the evidence. So the additional data is being sought for through the computer systems. Now let's look at AICA IT auditing methodology and rules for electronic evidence gathering. So the methodology for examining and reporting on electronic evidence. Step 1, we trace financial statement assertion back to workflow process controls. Then we map workflow processes to business network. We identify the custodian of the business network. We document transaction cycle by transaction type. We map transaction types to transaction network. We identify the custodian of the various transaction network. We reverse engineer transaction data. We map transaction data to specific repository, for example, database and data sets. We determine the chain of custody of transaction data, and we examine and test transaction lifecycle control. We examine electronic evidence, and finally, we report the findings. These activities must be planned and documented prior to commencement of the IT audit, which is under the ISC discipline. The plan can be updated during the term of the engagement, but proper documentation will include the subsystems that the plan is being updated to, examine the reason for the update, the test cases, data requirements, and so on. So this is the AICA methodology for examining and reporting on electronic evidence. So to summarize, the AICA methodology for examining and reporting on electronic evidence is to automatically identify and examine the relevant financial data and metadata that is generated in an automated business operating environment. Then we test and report irregularities and misstatement in electronically generated financial statement assertion. In the process, we trace the chain of custody of financial data throughout the data lifecycle, from the generation of the data to the final disposition of the data. So this is a schematic that describes that particular process of verifying the data. And as you can see, we have randomly selecting the data that will be used, the custody path. We tracing the custody of the data, if you look at the legend below, and the audit path. So the custody of data, for example, starts from the manager, went to the payroll service provider in the cloud, it went to the bank, that information got into the employee payroll account, and as number 5 and 6, the cloud from the payroll company, they were sending the information to the Internal Revenue Service, and then the ERP system to the company, and then the company bank was compensating the IRS or paying the IRS for this. So that's basically the chain of custody of the data traveling from one end to another. New audit risk and inherent risk for the 21st century cloud computing environment. The risk of client surveilling, auditors' work activities, and evidence gathering method and activities. Artificial intelligence enables computer systems to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision making, and real-time data analytics. So artificial intelligence perform these functions that humans used to perform. So these new systems are very intelligent. AI learns from new data, user data that is fed into the system and the metadata generated by the system. So the system is inferencing the information, the data that is being entered by user. The system does some inferencing and creating metadata. So they analyze user data and relate it to real life experience to make decisions. It enhances human performance and augments human capabilities. That's artificial intelligence, very powerful technology. So machine learning is a branch under artificial intelligence. Machine learning enables computer to learn things through algorithms that are designed to dynamically uncover strategic insights into user and system generated data. So these algorithms use statistical methods and inferencing technology to make predictions from the combination of input from data mines, which is databases, for example, the user data and the system generated data all in real time. The insight uncovered from combining the input from data mines and user generated data and system enabled decision making within the application of businesses. The aim is to derive relevant business questions from the insight and subsequently the data to answer key business questions and to solve business problems. So a final word of caution about AI and machine learning. Many stakeholders such as the AICPA and NASB, National Association of State Boards of Accountants, and now AIC are working diligently to bring the accounting profession up to 21st century IT auditing standards for cloud computing, the Internet of Things, which is smartphone, tablets, and so on, the artificial intelligence and machine learning. However, AI and machine learning can enable savvy technologists to spy on auditors electronically and discover the auditing methods, patterns, and other data points unknown to the auditor. So risk assessment should be conducted to identify areas of risk that the savvy technologists can see the footprint that the auditors are using. The footprint meaning what the auditors are looking for, what they're looking like, so that they cannot plan their evasive activities around the audit plan. So emerging technology. As artificial intelligence and machine learning proliferate in the marketplace at an unprecedented risk, and that trend will continue for some time to come, some basic and standard business routines, financial data processing controls, and financial data communications controls will be migrated from software to firmware. Today, most business algorithms are being implemented in firmware to support the vast array of Internet of Things devices that continue to increase exponentially. So AI and machine learning will drive the rapid advancement of migrating software function to firmware. Firmware is like chip technology that instead of writing the program and having the program execute in files, it is actually built into these devices such as chips. And so during the COVID crisis, for example, you heard the production of cars were slow. Were lower because of the lack of chips, and those chips have all the intelligence to make these cars move, just as an example. So edge computing, financial auditor will be required. These are emerging technologies that will give financial auditors more opportunities. So financial auditors will be required to devise methods and utilize the appropriate tools to assess and test the impact of migrating functions, software functions to firmware technology, for example, business data processing, business workflow, financial data processing, financial data transmission. So some of these functions will be moving from software to firmware, and they are also occurring in autonomous vehicles. And because as you can see, the programmers do not make changes to those firmware. The issue with the downside of firmware is that once this program into the firmware, you will have to change the entire chip in order for that to update the program. So again, edge computing architecture support content distribution network, edge servers that are deployed as closely as possible to the user. So edge server hosts application databases, shopping carts, for example, real-time data processing application, and advertisement engines. So when we talk about edge computing, what we're talking about, because every time let's take for example the mainframe environment. Every time you try to access from the dumb terminal to the mainframe environment, you try to access a program, it had to go over the little network that was established between the dumb terminal and the mainframe. So because of all these millions and billions of devices that are on the internet, they want for the processing to occur, to slow down, to increase bandwidth and not to overuse bandwidth. So most of the processing is, for example, a shopping cart. You pick all of the things you want on your smartphone or your tablet. And once you're done, then the shopping cart, you click or tap on the button and the shopping cart goes and back to the system that it belongs to, and then it calculates how much you owe, and it's done through the PCI DSS network we'll talk about later on. Then your credit card company pays for it. So in other words, the processing is occurring locally to avoid data going back and forth on these things and decreasing the bandwidth. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the sources of the data. It improves response time and conserve bandwidth. So as I said earlier, a common misconception is that edge computing and IoT are synonymous, which is the Internet of Things. Edge computing is not IoT, it's the networking topology, which means the Internet of Things, which is the tablet, the laptop, the tablet, the smartphones. They are all what we refer to as the Internet of Things, but the edge computing is a networking topology, which means that it's a structure of the network that enables you to process data on those IoT devices locally and then send the data once that transaction is completed, again, to save bandwidth. The term edge computing, again, is referred to as a computer networking architecture rather than a specific technology. The relevance of each chapter in the AICA series of books to the integrated audit of financial statement controls and the internal control over financial reporting. At the end of each chapter in these books, we explain the relevance of the chapter to the integrated audit of financial statement and the internal control over financial reporting, and how each chapter relates to the new AICPA CPA Evolution Model Curriculum ISC Discipline Curriculum requirement. For example, we explain why auditing transaction cycle and accounting cycle is a required standard regardless of whether the business environment is automated or paper-based, even though, as we described earlier, the approach and the method will be different, but you still have to audit transaction cycle and accounting cycle. Similarly, how confirming cash is required whether the business environment is completely automated or paper-based. So in the past, when you wanted to confirm cash, you had to send a confirmation letter or request it from the bank to show how much money was in the bank. Today, you can access the bank database directly. And of course, there are methods you use to gain access directly to the company's segment of the banking networking infrastructure. So conclusion. To end this introductory section, I will leave you with the following statements to ponder. Cloud technology has decentralized all of the functions, features, and services that were performed at the corporate headquarters and the various branch offices via mainframe computer and dumb terminals. So cloud computing decentralized all of that. And blockchain put the structure around the resulting disjointed processes cloud technology has created. And the following diagram illustrates this phenomenon. So this is the diagram, and it shows you. You can review these slides for yourself, and don't forget that you can always use your pause button to go back, rewind, and pause button to review this. I've gone through it, and there are more details you can obtain just by going back and forth. So to summarize what we talked about, we define computer systems in the context of IT auditing. We clarify computer terminology. We talk about IT general controls and business process controls. We explain the evolution of computing architecture. We explain the evolution of computer system. We talk about scope creep, how you put logical marker around it. We discuss the audit universe. We explain why generally accepted auditing standards are outdated. We explain why the current financial auditing tools and platform are inadequate. They are just document management systems, workflow platform, configure workflow platform, and query tools. And we discuss the difference between audit evidence in the paper-based environment versus an automated environment. We also describe AICA methodology for obtaining, examining, testing, and reporting on electronic evidence. And finally, we discuss the impact of emerging firmware, IoT, and machine learning technology on financial statement auditing. Hopefully, I have given you a general overview of what you will learn as you navigate the thousands of pages of our currently 9 AICA books. All of them are designed for different audiences. So go to the playlist and see the audience and the books that are applicable to that audience and our training programs as well. We have collaboration with textbook writers. The American Institute of Cloud Auditors offers to collaborate with textbook writers. Please direct all collaboration requests to services at aicamembers.com or visit www.aicamembers to submit your collaboration request. Thanks again for your undivided attention. I'm Robert Llewellyn Kilby, and I'm the Principal Auditor for the American Institute of Cloud Auditors.